Good morning, students. In the previous class, you might have seen about the topic electric field. So our topic today will be electric field due to a point charge first, then electric field due to a system of point charges. So first, a single point charge has the simplest electric field. First we must know that a single point charge will be having a simple electric field. So in the previous class you have seen about the source charge and test charge. Just a small introduction on that. Consider point Q placed at the origin O. Now consider point Q at the origin O, which we call it as source charge, and a test charge is brought near to the source charge at a distance of R. So by the electric charge, it is either attracted or either repelled. So there is a force which is created from the source charge to the test charge, and a force has been indicated by F. So according to Coulomb's law, F is equal to 1 by 4 pi epsilon 0 into Q0 divided by R square into R vector, where F is the force which is created from the two charges and epsilon 0 is the permittivity of free space, and Q is the source charge and Q0 is the test charge, and R is the distance from the source charge to the test charge. So this is Coulomb's law. So once you get the force from the source charge and test charge, next you will be calculating the electric field at a point P. So we already know the formula. Electric field is equal to force by source charge. So for the force, we will be substituting the Coulomb's law, 1 by 4 pi epsilon 0 Q divided by R square R. So now you can calculate the force as well as the electric field. Force is calculated by the Coulomb's law, and electric field is calculated by the force divided by the test charge. Based on this, the magnitude of the electric field can be calculated. So the magnitude of the electric field will be 1 by 4 pi epsilon 0 into Q by R square. E is directly proportional to 1 by R square. That is, electric field is directly proportional to 1 by distance. So all points on the spherical surface drawn around the point charge, they will be having the same magnitude E. That is same electric field, and it does not depend upon the direction of on any side. Such a field is called spherically symmetrical or radial field. So based on that, we are just going for seeing a system charge on a point charge, which will be having around it a lot of charges in a spherical way. So first we will see a common example related to this. Take a bucket full of water. You can see that bucket is transparent, that it's filled to this level water. You see that the water does not shake. Then just take a small stone and just put the stone into the bucket of water. Already the water was still in condition without any shake. Now you are throwing this stone inside this bucket of water. Once you throw inside the bucket of water, the entire water gets disturbed. You can see that the stone goes straightly down, disturbing the water molecules. So what happens? All the water molecules around it is being disturbed, and it creates a spiral form to the end of the bucket. So this is not a new concept. In the beginning, by the creation of the world itself, God has made the concept of electric field. So if you just check it in the Bible, if you turn to Psalm 19:6 second part, and its circuit unto the ends of it, This circuit indicates that the electric field is passing from the center point of it towards the end of the inner circuit. So electric field is nothing but it's a old concept. Only thing is we are just going to study now and put it as a in practical way and model it. The water molecules disturb another particle and it will disturb another particle, and it passes on like this and it makes a big circle. Similarly, an electric field also has a charge which keeps on extending from one to the next, and it keeps pushing on to the and makes it in a spiral way. So inside, if a point is there, around it there will be a set of charges in spiral way. So we need to calculate all this. I hope you might have understood the basic concept about the point charge in spiral way. So dear students, just look on to the next one. Electric field due to the system of point charges. Now we are going to do it in mathematical way. So you can see here there's a charge which is a test charge. So different charges are acting on this particular test charge, that is it's pushing. As I told in the previous one, the molecules of water will be pushed by the next molecule and the next molecule, like that. Similarly, this charge pushes to this particular test charge. From here another charge is pushing to this test charge. So what happens? An electric field is being generated in different directions. So it moves in different direction. A force is generated in different direction which creates the electric field. Now at the center there's another one, test charge. So what happens? That's an electric field which has been created on the side, has been added E1 plus E2. So let us consider a system of n point charges which has Q1, Q2 up to Qn, having a vector position of R1, R2 up to Rn from the point O. So we have to consider a system of charges which is having Q1, Q2, Q3 up to Qn, and having a vector, that is the distance of R1, R2 up to Rn from the point O. Our work is determined that at the point P. Now we'll apply the Coulomb's law. So according to Coulomb's law, the force on the test charge Q0 is exaggerated from Q1. So Q1 is exaggerating a force to Q0. So we are calculating the force. F1 is equal to 1 by 4 pi epsilon 0 Q1 Q0, that is this Q1 and Q0, divided by R1P, this distance R1P square R1P vector. So this is the force on the test charge. This force is acting on this particular test charge. So once you can find the force on the test charge, you can easily find the electric field, because electric field is nothing but force divided by the test charge. So it's equal to 1 by 4 pi epsilon 0 Q1 R1P square R1P, that is this R1P is the distance, Q0 and Q0 will be cancelled. So once if you know, you can find out the electric field of Q1, you can easily find the electric field of Q2, I mean the second source charge. So E2 is equal to 1 by 4 pi epsilon 0 into Q2 by R2P, Q2 R2P, that is, so if you can find the source charge of Q1, Q2, you can also find for the source charge for Q1 plus Q2 up to Qn. All the source charge will be having the electric field with the same formula E1, E2. Only the thing is you have to change the Q1, Q2 in the particular place. You can see here it's been changed only Q1, Q2, Q1, Q2. If it's next Q3 means you have to change your Q3. If it's R3, you have to put R3. And it keeps on up, and this is what we call it as principle of superposition of electric field. So according to principle of superposition of electric field, the electric field at any point due to a group of charges is equal to the vector sum of electric fields produced by each charge individually at that point, when all other charges are assumed to be absent. So based on the principle of superposition, we are going to add all the electric fields E1, E2 up to En. We get an electric field, that is E is equal to E1 plus E2 plus dot 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 En. So for each electric field, you will be having the common factor 1 by 4 pi epsilon 0. Then we put it in bracket and just take the charge Q1 here R1, then it's Q2 R2, Q3 R3 up to Qn Rn. So adding all these things, you can find the total electric field, that is total strength of that particular charge. So this gives a good formula for calculating the electric field strength for a particular point of charge. So the electric field is calculated by 1 by 4 pi epsilon 0 by means of the summation, all the added one by mathematical summation. We make it as Qi by Rip square R suffix Ip vector. Now dear students, you just remember this formula, this very important formula for calculating the electric field for a system of point charges. So you can see here, from the point P, you can calculate all the electric field E1, E1 plus E2, E1 plus E3, E1 plus E3, E1 plus E2 plus E3 plus E4. So around this there will be a set of charges which has been marked here. So electric field at a point due to a system of charges is the vector sum of the electric fields at the point due to a individual point. So from this, the unit is been calculated. When Q is in Coulomb, Q is charge is in Coulomb, and R is nothing but it's a distance in meter. So E is in Newton per Coulomb. Therefore, for an electric field due to a system of point charges, you have the formula E vector is equal to 1 by 4 pi epsilon 0 summation of I is equal to 1 up to n Qi divided by R Ip square R into R Ip vector. That Q is nothing but it's the charge and R is the distance, epsilon 0 is the permittivity of free space, and n is the n number. So with this you can calculate the electric field for a particular point, how much electric field strength it's acting on it. So we use the unit newtons per coulomb. We use the unit. So based on this, let's see a small problem related to this. Assume that the charge on an atom is distributed uniformly in a sphere of radius 10 to the power minus 10 meter. 10 to the power minus 10 meter. What will be the electric field at the surface of the gold atom? For gold, Z is equal to 79. So let us assume that the charge is concentrating around the radius of the sphere of 10 to the power minus 10 meter. Around that sphere, around that particular sphere, the charge is been concentrating like this. This particular area we are going to calculate now all the distance. It's 10 to the power minus 3 meter. Therefore R is equal to 10 to the power minus 10 meter. And the charge is equal to Z into electron is equal to 79 into 1.6 into 10 to the power minus 19 Coulomb. So 1 electron is 1.6 into 10 to the power minus 19 Coulomb. As Z 79 has been given here in the question itself. Now we are going to calculate the electric field. So E is equal to 1 by 4 pi epsilon 0 into Q by R square. Substituting the values here, so answer will be 1.338 into 10 to the power 13 Newton per Coulomb. This is the charge which is concentrated around this for a single particular point. So dear students, I hope you understood the very basic of the electric field due to point charge and electric field due to system of point charge. You can also subscribe our channel Sharp Physics. We will be updating it frequently and we will try to make it as easy and short as possible. Thank you.